In this lesson, we're covering 1- and 2-step equations. The main thing to remember when solving equations is the golden rule of equations. And that rule says, do unto one side as you would do unto the other, or as you do unto the other. So you have to think of an equation as something that is balanced. It's like a balanced board on a fulcrum like that. And if you do something on this side without doing it on this side, then it's going to flip down, right? So think about this. If I just put it there, then that's going to end up being unbalanced. That's going to end up down here. So we want to make sure that we do anything we do on one side to keep it balanced, we do it on the other side. Now, what we want to do are opposite operations. Okay? So there's the addition property of equality. And we could also include subtraction with that. Those go together. And it says you can add or subtract any number as long as you do the same thing on both sides. So add or subtract any value from, add to or subtract from, as long as it's both sides. Okay, that's what's critical. You can't just do it to one side. You'll be out of balance if you do. So whenever you have something that's addition, remember that's going to be a plus sign. You're going to have to undo that with subtraction or a minus. So these undo each other. Now there is the multiplication, which goes along with division. Property of equality. And it basically says the same thing for multiplication and division with one exception. You can multiply or divide by any non-zero value. Can't do it with 0. Can't divide by 0. Can't multiply by 0. As long as you do it on both sides. It's got to be the same thing, both sides, like we said before. Okay? Now remember, the goal of solving equations is to get the variable equal to a number, when possible. And that means that that variable is isolated. And I put an M, but it could be an X or a T or an S. It could be any variable. And remember, that means that this number in front, called the coefficient, has to be a 1. So you can't have a negative there. You can't have a 2 or a negative a half or anything. It has to be the variable by itself with a positive 1 coefficient. So let's do some examples. And these are the 1 steps. If I have, example 1, y plus 11 equals 15, and my goal is to isolate that y, I'm going to have to subtract an 11 from both sides. So y is going to be 4. And of course, you can check that by putting the 4 in for the y. 4 plus 11 is 15. And you know, occasionally you'll be able to do these in your head. But even with the easy ones, you need to follow the process so that when they become more complicated, you know a good process. Okay? Example 2, 23 is equal to y minus 8. Now, there is no rule that says that the variable has to be on the left. It can be on either side. So I'm trying to isolate this y. I'm going to do the opposite of subtract 8. I'm going to add 8, to both sides. I almost subtracted on one side. You have to do the same thing on both sides. So 31 is y, because negative 8 plus 8, that's just 0. Okay. 4, this is example 3, is equal to a minus 1 2/9. Well, I'm going to have to add a 1 2/9 to both sides. So that's going to give me 5 2/9 equals a. Now, do they say we can have a mixed number? They do. So we're going to leave that as 5 2/9. And you can use your calculator and your ABC key, your fraction key on your calculator, to do fractions as necessary. Example 4, I have a decimal. I'm still going to follow the same process. I want y to be isolated. It's a 1 in front of that y. All I have to do is add 15.83 to both sides. And of course, you can do the arithmetic if you want to in your head or on the paper, but the safest thing to do, especially while testing, is to do it, the long way, but then check it on your calculator. 7.69 plus 15.83 gives me 23.52 on the right side, and y equals on the left side, 23.52. Now, all of those first 4 examples were add, subtract, and I did the opposite. When there was an add, I did a subtract. When there was a subtract, I did an add. And now, in number 5, I have a multiplication. Negative 6 is equal to 2y. Now remember, I'm trying to get this y by itself. I cannot subtract a 2 from a 2y. That's multiplication, so I'm going to have to divide both sides by 2, okay, because multiplication, the opposite operation of that is division. And I don't know if I said that before, but those are opposite operations. So I divide both sides by 2, and negative 3 equals y, because 2 goes into 2 and leaves a 1. And remember, we want a coefficient, or that number out front, to be a 1. So our final answer here for number 5 is negative 3. In number 6, again, I have multiplication. 19 times a is 0.095. I want to isolate this variable a. It's being multiplied by 19. I need to divide it by 19. If I divide on the left, I must divide on the right. 19 goes into 19, leaves a 1a, and of course we just write a. And 0.095 divided by 19 gives me an answer of 0.005. 005. And of course you could check that. If that's true, then 19 times 0.005 should come out to 0.095. 19 times 0.005 comes out to 0.095. So It's a great idea to check these, especially on a test. All you do is substitute and make sure each side is equal. Number 7, 35 equals negative 10 times y. Okay, and so they don't write the times in there. They just write the y, but that means the same thing. I've got multiplication. Therefore, I need to divide both sides by negative 10 because I'm trying to isolate this y. Now, I have to divide by negative 10 because I want a negative divided by a negative to give me a positive 1. And let's see, an integer or a decimal. So I'm just going to do this on my calculator. 35 divided by negative 10 is negative 3.5. Negative 3.5 equals 1y, which is just y. So negative 3.5. Example number 8. Little tricky, but you got to think about this. Even though we're adding here, if I subtract another 25, so let me show you wrong first, so don't write this down. That's not going to give me a 0. A negative 25, that would be a negative 50 plus x equals 2. And that didn't help me at all. I need to do the opposite of that minus 25. So I need to do a plus 25 on both sides. Remember, this negative 25 plus x can be rewritten x minus 25. And there, that's telling me I need to do a plus 25. So this is going to be a 0. X equals 52. Practice doing it without your calculator. Use your calculator to check. Now, for the first time, we have a division. The opposite of division is multiplication. So in number 9, I have z divided by 1.8 equals 0.3. I'm going to multiply both sides by 1.8. I'm going to use parentheses for my multiply. You definitely don't want to use a dot here, and you don't want to use an x, so parentheses what makes sense. Now think about this. I've got a 1.8 over 1. So I've got a 1.8 divided by a 1.8. Well, that's going to be a 1. So this is z equals, we just do 0.3 times 1.8. 0.54. The final answer for number 9 is 0.54. So when you have division, that's a division bar, you're going to have to do the opposite of division, and that's multiplication. When you have multiplication, you divide. When you have division, you multiply. Number 10, m plus 17 equals 6. So again, my goal is to isolate that 1m. So I'm just going to subtract the 17 from both sides. So let's see, I've got m plus 17 equals 6. I'm going to subtract the 17 from both sides. I've got m equals negative 11. My final answer is negative 11. Just watch your sign numbers. You can do it on the calculator, or remember if they have opposite signs, you subtract. I have more negatives here, so I'm going to have a negative answer. Here I have multiplication in number 11. Negative 10y is negative 45. I'm going to have to divide because I have multiplication. Look at my format, integer or decimal. So this is going to be a positive 1. Negative 10 divided by 10, and we don't have to write that, so y equals 4.5. Multiplication, we have to do division. Number 12. Negative 4.7 is negative 6.6 plus q. Now remember, the letter or variable does not have to be on the left. We're just going to leave that q on the right. So I've got a minus 6.6. I need to do a plus 6.6. Plus 6.6. A negative 6.6 and a positive 6.6 gives me a 0. So I have a negative 4.7 plus 6.6. That gives me 1.9 equals Q. So my answer for Q is 1.9. Example 13. I have division. I need to do multiplication. I'm going to multiply both sides by 0.5. As long as it's not a 0, you can do this. And it doesn't matter if you put it in the front or the back, because A times B is equal to B times A. I just kind of squeeze it in where it will fit. Now remember, this is going to end up being a 0.5 over a 0.5. That's a 1. It's not a 0, it's a 1. So we have 1K equals 9.66 times 0.5. 4.83. My answer for K, my solution for K is 4.83. All right, so now we're going to go to two-step equations. So let's do a quick little review on that. Two-step equations. So they're going to be two operations to undo. Two operations to undo. You're going to, number one, undo, add or subtract. And number two, undo multiplication or division. So you're going to have one of these and one of these. Okay? You'll have add or subtract, and you'll have multiply or divide. Now, it's opposite of the order of operations because we're going backwards and we're solving now. So, I have a two-step equation. 8x minus 9 equals 55 for number 14. 8x minus 9 is 55. Well, I'm going to add 9 on both sides because I'm going to undo my subtract first. And remember, I'm focusing on getting this x by itself. Well, the negative 9, positive 9, that's a 0. So I have 8x equals 64, but I'm not finished because I need a 1x. Look, I'm looking for the value of a single x. So here I've got multiply, I have to divide by 8. X is 64. So you need to do the add or subtract first, then do the multiply or divide. Number 15, 2.5m minus 4.1 is 2.9. I'm trying to isolate the m. First thing I'm going to do is undo the subtract 4.1 by adding 4.1, following the golden rule. Do the same thing on both sides. 2.5m, this is 0, equals 2.9 plus 4.1, which is 7. 2.9 plus 4.1 is 7. And now I need to divide by 2.5. I've got to undo that multiplication. So m is 7 divided by 2.5, which is 29. no, 2.8. So M is 2.8. Example 16. 11 minus 5n, this one's going to be a little harder because I got a negative there, equals negative 29. And we just have to watch our signs. I've got to get rid of a positive 11. Look, that's a plus 11. I'm going to have to do a minus 11. If I do another plus 11, that's going to be a 22. That's not going to do me any good. What I want is to get that negative 5n by itself. That's a 0. So I get negative 5n equals negative 29 plus 11 is going to be negative 18. I've got to divide by negative 5. N is 18 over 5. So we're just going to leave that as that reduced fraction. There's no common factor in 18 and 5. I don't know if it'll take the mixed number, which is 3 3/5. I certainly would if you took a pencil paper test on campus. I'm not sure what my math lab will take, so you just have to play around with it and see. Now we got a problem here. It's different. Look, 2z minus 5z. I need to go ahead and subtract those first. Negative 3z is 15. So you don't want to start undoing anything if you have like terms that can be combined. So the first thing I do is combine those. Now I know I just have multiplication, so I'm going to divide both sides by negative 3. And so z is minus 5. Number 18 has that 24 and that divide by 7. So let's see. 24 minus x over 7 is 13. I need to isolate the x. I start by getting this 24 away from the left side. So I'm going to subtract it. Whatever I do to the left, I do the right. Now don't forget this sign. You have a negative x over 7 equals a negative 11. 13 minus 24 is negative 11. Now look, I've got a negative x over 7 is negative 11. I've got to divide by 7, so I can go ahead and just multiply by 7 first. So I'm going to go ahead and put my parentheses around this, multiply by 7. I got to do it on both sides. 7 divided by 7. 7 on top, 7 on bottom. Now, it's going to leave a negative x equals negative 77. Now, remember, our goal is to get a positive 1x. Okay? So there's a negative 1 being multiplied there. So I'm going to have to divide both sides by negative 1. And that's going to leave me with a positive 1x, and this side's going to be a positive 77. Now, if you have any kind of simplification that can be done, you need to do that first. So you're still just going to have two operations to solve the equation, but the first thing I have to do here, negative 11 is 3 minus 5x plus 12x, is I need to clean up that right-hand side of this equation. I have a negative 5x and a plus 12x. That's going to be 3 plus 7x. Now I can start to solve for this x. So I'm going to undo this plus 3 first. I need a minus 3. That's going to give me a negative 11, a negative 3 is a negative 14. That adds to 0, so I'm left with just a 7x. That's 7 times x, so I need to divide by 7 on both sides. Negative 2 is the value of x. So don't start trying to move things until you have simplified each side as much as possible. Example 20. 1/2 plus 10x equals 1. I'm going to focus on getting that x by itself. The first thing I will do is subtract a 1/2, and I get, this is a 0, so I'm left with a 10x equals 1/2, because 1 minus a half gives me a half. That's 2 over 2 minus 1 over 2, which is a half. I've got to divide by 10 this time. So I've got x is equal to 1/2 divided by 10. Now, certainly you can do that on your calculator, but if you remember when we did fractions, we said when you divide fractions, you got to multiply by the reciprocal. So that's going to give me 1 over 20. Okay, you've got to follow those rules for fraction division. And a whole number 10 is 10 over 1. I flip it, it becomes 1/10. Remember, it's change, flip. Change divide to times, flip 10 to 1/10. Number 21. Negative 5a added to 44 is 24. So I'm going to want to move that plus 44 first. So I'm going to minus a 44. Follow the golden rule. Do it on both sides. Show your work. Show your steps. Negative 5a is negative 20. 24 minus 44. Now I've got multiplication. I need to divide on both sides by negative 5. Negative 5 divided by negative 5 leaves a 1a, and I'll just write a. And a negative divided by a negative is a positive. A is 4. In number 22, we have negative 3z plus 1/2 equals 20. So that's negative 3z. Let me take that back. I want to move that 1/2 first, so subtract a half, right? Because I want to get that z by itself, so I don't want to start doing anything to that yet. So I've got a negative 3z, because this is a 0. Now look at the difference. When you divide a number by itself, you get a 1. Because you're doing the opposite operation, you got to divide by the same number. But when you're adding, you add opposites and you get a 0. Now, 20 minus a half is 19.5. I mean, just think about that. You got 20 and you lose a half, you're at 19.5. So I've got to divide this by negative 3. So z, oops, sorry about that. Z is going to be 19.5 divided by negative 3. So let's take a look at that up close. I have 19.5, and I'm going to divide that by negative 3. Okay. First, I have a positive, right? Positive divided by a negative, and that is going to be a negative. So I know my answer is going to be a negative. All right. Now, we don't ever do operations with mixed numbers. We change them over to improper fractions. And of course, you could do this on your calculator, And I'll do it on mine to check it in just a minute, but I want to show you what actually happens here. You're going to take your 19 and a half. You're going to change that. 19 times 2 is 38. You're going to add that numerator. That's 39 over 2. And I've got to divide that by -3. Now, how did I get that? I did 19 times 2 plus 1 over 2. That's how you do a mixed number to improper fraction. Improper doesn't mean bad. It just means the top is bigger than the bottom. Now, this -3 has a denominator of 1. So this is we're going to do the change flip. Change that, flip that. So I've got 39 over 2 times -1 over 3. And it really doesn't matter where that negative ends up. Okay? You can put it in the top with a -1. You can put it even with the bar, which is really the most desirable. Or you can put it down here in the bottom. It doesn't matter. Because remember, you got a positive. Now it's times a negative, so it's going to be a negative. Okay? Now, when you have a factor on the bottom, when you're doing fractions, that'll go evenly into anything in the top, you can just divide that into that and get a 13. 3 into 39 is a 13. Or you can do top times top, 39, bottom times bottom, 6, and remember this whole thing is negative. But we want to reduce our fractions to lowest terms, so this is divisible by 3, and this is divisible by 3, so we get -13 over 2, which is what we would get here if we went ahead and reduced that 3 into that 13. Now, on my calculator, 19 ABC 1 ABC 2. Your calculator can do mixed numbers divided by negative sign 3. So 19 and 1/2 divided by -3, and it gives me -6.5. Excuse me. And notice that -6.5 is equal to -13 over 2. If you change that, -6 times 2, and I'm going to do my negative last. I'm going to do the 6 times 2 plus 1. 6 times 2 plus 1 over 2. And now that's negative. That's -13 over 2. Now, let's look at the format that they ask us for. They may ask us for a mixed number. They may say mixed number's fine. You know, in the real world, it makes a whole lot more sense than an improper fraction anyway. You wouldn't go to Home Depot and say, I need 13 over 2 boards. You'd say, I need 6.5, whatever. All right, so let's look at what they say. Type an integer, a proper fraction. They don't want the improper fraction or a mixed number. So they want the -6.5. So with those fractions, it's going to be more complicated, but use your calculator. Practice doing it by hand some, especially if you're in a field or you have a technical degree where fractions are involved, like carpentry. Okay. Number 23. 7 minus 24x equals 3. My goal is to isolate the x, so I'm going to subtract a 7 first. 7 subtract 7 is a 0. I'm left with -24x equals -4. 3 subtract 7 is -4. Pay attention to what operation you're doing. Divide that by negative 24. X is a fraction. Negative divided by negative is a positive. That reduces to 1/6. And so simplified fraction would be 1/6 for that one. Okay, so undo the 7 first. The very last thing you want to do is whatever is right with the x. Are you being multiplied or divided? Do that last, always. Example 24. Negative 4a plus 35 equals 19. I'm focusing on getting that a by itself. I subtract 35 first. I get a negative 4a is 19 minus 35. That's negative 16. Since that's being multiplied, I have to divide by negative 4. A is equal to 4. And number 25, I've got a 3x over a 7. So that's a times and a divide. Now you can do those separately or you can do them all at one time, okay? The best and easiest thing to do when you have a fraction in front of your x, your coefficient is a fraction, 3x over 7, is do it at the same time by multiplying by the reciprocal. Think about that. You're going to get a 21 over a 21. That's going to give me a 1x. Negative 63 divided by 3, right? Because when you multiply, times top, bottom, or I could do that into that. 3 into 9 needs a 3. That's either way, it's going to be a negative 21. Now, let's talk about what you would do if you want to do those separately. First, let's multiply by 7. Parentheses is probably best, especially if there are decimals in the problem. A 7 on top and a 7 on bottom divide to a 1. A 1 times 3x leaves a 3x. A negative 9 times 7 is a negative 63. Now I've got multiplication. I divide by 3. X is negative 21. So when you have a fraction coefficient, you can do the reciprocal or multiply then divide. You can do it in either order. So our final answer for this one was negative 21.